In this lecture, we'll cover the theory portion of friction losses in pipes and also friction loss in the sudden expansion and contraction. So those are the two things we're going to cover. And we'll start with, first of all, basic understanding of how do you measure the pressure head and how the loss is associated with the friction loss in pipe and things like that. So to do that, we need to go back and revisit our Bernoulli's theorem one more time here, very quickly, only just a couple of formulas we're going to go through. And here is the, let's understand what Bernoulli said. There are four statements are there. Equation is the relationship between velocity, pressure, and elevation. So as the fluid is flowing through, this is the relationship between elevation, velocity, and pressure. And it is also an energy conservation equation valid for incompressible frictionless flow. Again, remember the word frictionless, but we are measuring friction. I'll show you what I meant by that. And the third one is total energy of a fluid flowing without friction losses in pipe is constant. So in our case, since we have friction, it won't be constant, but we are using the theory to understand how you are measuring the pressure. We'll talk about it. So total energy is the pressure energy, kinetic. So this is the point I was trying to make. When you're measuring, there are three types of energies are there. One is the pressure energy, velocity energy, elevation energy. So this is a formula we use for that. So next thing on the Bernoulli's is you can write Bernoulli's in a different forms. Since remember I was talking about pressure head, and this is where the pressure head comes. So Bernoulli's equation can be written in pressure form and head form. I want you to understand the three components. One is the pressure component, which is a static pressure head, and then another one is a dynamic pressure, which is associated with velocity, and the other term is hydrostatic, which is associated with elevation. So the elevation is different, and you have that. So what you're saying is, if there's no friction, it would be constant. But in our case, there is a friction there, and it won't be constant. So that's the point I was trying to make. But I want you to understand why are we using pressure head to measure the friction losses. That's the point I was trying to make. So from just it's a theory to revisit or review what Bernoulli's theorem is. So from here we switch our gears and go to the focus what we have, which is friction losses in pipes. Okay, let's talk about what are the friction losses and things. So we remember the word pressure head, that is pressure over specific weight. You know, the formula is given. It can be written P over rho g, that is gravitational force, and density, that is the pressure head. And so again, refreshing, we said there are three heads are there. Velocity head is there, pressure head is there, and also that is what he is showing here is velocity head, and then static head. The three different heads. So in that one, when you're really applying in a pipe, now we're applying the piezometer, how we're measuring it. So you have tap 1 and tap 2, right? So in this equation, if you look at it, since it's a constant diameter pipe, it's not changing, and the elevation is same, so elevation head is gone. There's no change in elevation. Okay, that's good. And velocity, since it is again constant diameter, there is no change in diameters, so velocity would remain same. So here, horizontal diameter at a pipe, Z1 is equal to Z2, V1 is equal to V2. So if you plug those equations, then all you end up with pressure at point 1 and pressure at point 2. And that's what we did when we were trying to remember I was showing you pressure tap 1, tap 2, and also. So that's what we're using. And then this is connected to the formula that pressure head or the friction loss equal to such and such, such and such, such and such. So that is the point I was trying to bring it up. So now I connected Bernoulli's equation to this form of pressure head. Okay, and then head loss type. And here is a formula for the head loss. Major loss is the friction force, length over diameter, velocity square, or 2g. That is the formula for the head loss due to friction. So if you are interested in finding a friction and you reverse the formula, just you focus on friction. And so that is it. And then also if it's the things have like major loss, minor loss, and also laminar flow, a lot of things are there. And we use Modi's chart. This slide is important. Take time, go through it, and so you understand what are the different variables you will be covering to measure the friction. So, but the basic formula is this one. Friction loss, I mean head loss due to friction, head loss due to friction is F L over D V square 2G. That is the length of the pipe. The function is head loss is directly proportional to the length of the pipe, and the diameter of the pipe inversely proportional and directly proportional to the velocity. So, depending upon how much the velocity is, it is also directly proportional. That's what I want you to get out of this slide. So he's showing the friction head. How do we do it? I think I went through that. The next more important thing is you need to understand how to use the Moody's diagram, and how provided the link. Very nicely done. I want you to go through this link. It is a part of my class slides, and so take your time, go through that, and so I'll share that link later on in the class slides. So what else we should cover here? Okay, so what we'll do is from here we jump to the experiment. How do we do it? What are the things there? I just briefly covered in the first part of the video the apparatus itself, and then I'm going to switch my gears, go to the manual itself. Now here is the manual. The manual we'll be using is H408. Now we are interested in measuring the friction losses, one in smooth pipes, other in the rough pipes. Okay, so those are in the manual. Everyone can see my cursor here on the top. So if you type it in, the material for this one and also the tables you have to prepare is all in the pages, starting from 18, 19, 20. So if I just type it here, not the page number, this is the page number I'm talking about, 18, where I'm typing it in. It takes you to this point, and somewhere here is the notations showing you all the variables you will be covering. Is the kinematic viscosity and flow, volume, Reynolds number, all the variables you will be encountering. And so I want you to know the units. If the units are messed up, you will have problems. So these are the units I want you to use in your experiments when you're collecting the data and analyzing the data. Not only collecting, analyzing data. So from here, I'm going to scroll down to see. Okay, now first thing is comes in losses in straight pipes. That's on page number 19. Okay, so it was showing you how to do the experiment. I'm not going to go through that, but I'm just going to show you where they are, and then the tables you need to collect the data, and then formulas associated with a smooth pipe. Remember, H is equal to 4 over FL square. Same formula which I showed you in the theory is here, and then also then also a typical calculation, which is very important. So if you have questions in your mind, you can always go back and see, hey, how to calculate all the different variables. So I think probably you should use that table. So that's for the smooth pipes. Now, if you had to, we also said we're going to measure the rough pipe. We start from page number 21. Here it is, rough pipe. Understand this theory here, how the rough pipe is, or what is the effective diameter. That's very important. You need to understand that. And then it also shows you how to do the calculations, right? So Moody's chart is next. I think we talked about the Moody's chart, and I'm going to give a special link that you follow through. That way, it is you know how to use the Moody's chart. So we cover literally how to do the experiment and the procedure wise, how to collect the data, and so this is for the for smooth pipes and rough pipes. But to get sudden expansion is also part of this experiment. I want you to go to the page number 27. Sudden expansion and sudden contraction. all the information is here. Again, procedure is there for you, how to do it, and tables are there for you, what are the data you should collect, and also the little bit of theory also he explained, and the formulas associated with it. So pretty much all the information what you needed is also baked into this one. Okay, so you certain expansion is one and certain contraction is there, and so now next question comes. Okay, I went, I used it friction apparatus, I collected all my data, I tabulated all of them. How do I present it? So I'll show you a sample example of what I'm expecting when it comes to the report writing. So you start with a page explaining everything, how the members of the group is. Start with abstract introduction. I think we have a special lecture we devoted how to write the report, because all the information has to be there. Okay, and you start with the introduction. You give the theory. You should have formulas associated with it for smooth pipe and rough pipe, and expansion also. What are the formulas you're using it, and then diagram, which because you're using this, which apparatus are you testing it? So H408, that's the apparatus. I think the apparatus name is very critical, because if somebody in Timbuktu trying to duplicate this experiment, he should know what apparatus you are used, because nowadays it's a global system. You'll be designing your components here, but they are being tested in Luxembourg or some Japan or something. So you need to show what apparatus you used, how you tested it, and things like that. So the procedure was very important. So that's why it was added. And the results, you tabulate all the results nicely, clearly, understand all the formulas you used to calculate this Reynolds number, friction factor, blasts, and all those kind of things. And then so we don't have any friction for smooth pipe and rough pipe, any graphs, but we do have some graphs for the sudden expansion. Here is one graph, and then contraction, another graph. So, and then you go to the discussion. You talked about what all the things you saw, observed, and you capture all those information, and then you finish your report with a conclusion. So conclusion is here. Okay. So with that one, I'll close this. But you have a general idea how to do the testing for the smooth pipe, rough pipe, sudden expansion, sudden contraction, and also how to write the report. So that encompasses all the things what we have. And when we're doing the experiment in person, we'll share a lot more information, the nitty-gritty details of the experiment and what it means and things like that. With that one, I'll end the session here. We'll be covering how we measure the pressure head drop, frictional losses in the pipe. So the equipment we use is called H408 fluid friction apparatus. So there are a lot of instruments are on this unit now, but we're going to focus on how to measure the friction losses in the pipe, and and also just a brief description of how the apparatus works. To make this apparatus work, we need a water source, and here is the basically you can call it as a water pump, and so it has a reservoir of water, and then connected. There's a pump, a centrifugal pump is mounted inside it, and then by powering it, you can control the amount of water flowing out of the system. So this is the inlet coming out of it and connected to the inlet of this frictional apparatus, and then exit. There is another tube coming out and dumping back into the unit. So that is the setup. Now, so this is just think about it as a water source to bring the water into the system, fluid basically. Okay, so in this setup, what you see is there's one set of tubing that is where the fluid is coming in and branching into three different configurations, and then exiting from the this apparatus, and then going back into the water is dumped back into the source. Okay, so to control the water, one means is using the pump. How much fluid it can go through, and also other thing is since we have three different lines of flow, we want to control one flow line at a time, depend upon what our needs are. So to control the flow, the color system is designed such a way, like a dark blue color coming out all the way and then connected back. That means if you're using that tubing to do some testing, you'll be using the gate valve on the top. So contrast to that one, if you are using a kind of gray type of line, and it is coming through and it coming out and it again going back, and then you will be using this portion of it. For the light blue, you have another setup. So there are 3 different valves out there. They are also controlling the amount of flow leaving the frictional apparatus. So that's how the system is set up. Now for our experiment, our focus is friction loss in a smooth pipe and also friction loss in a rough pipe. So the pipe we're going to elect is light blue color. That's the light. And then you are trying to, as the flow is going through those lines, to measure the friction, you need to know the pressure head loss between those 2 points. And that's where, for example, in a blue pipe, we are trying to tap, I think, I believe which one is it, 10 or something? And then, I mean, the note tells you what it is, and then the other tap is on the other side. We use those taps to measure the flow, friction loss in that pipe. The little correction, we're using a 10 and 11. And so now when it comes to measuring the friction loss on the rough pipe, so we're using the different setup, and we're using the gray color. Previously we used blue for the smooth pipe. Now we're using a gray color that it comes out, and then here is the rough pipe. It says rough pipe here, and we're tapping 30 and 31. So those pressure taps we'll be using. What is a pressure tap doing? We're trying to measure the pressure head in the beginning, 10, and also pressure head when it is leaving, 11, 10 and 11. So now, how are you measuring the pressure head? We use a piezometer which measures the pressure differential at 0.1 and 0.2. For example, 0.1 is 10. We take this piezometer tube and we connect it. So a continuation of our lecture. Since we are measuring the pressure head in the pipe, and so we use the piezometer. Piezometer has 2 tubes. One tube is the inlet where the fluid as is coming from the source of the tank, and it also going back to the going back to this to the hydraulic friction tower. So what we're doing is we're measuring the pressure head drop between 0.1 and 0.2, and that's what we're going to measure here. So it has a scale up and down, and you measure the differential that gives a head loss between the pipe. So you do the same thing when it comes to measuring the rough pipe. In our case, we have using the tap pressure 30 and 31, and you after done with the smooth pipe, and you switch your pressure tap to this one, and also you have to switch the valves and things like that, so that you're getting the right flow in the right circuitry, fluid circuitry. So that is basically how it is done. And the following lecture, I'll give you what is the pressure head, why it matters, and how are you measuring pressure, what are the formulas associated with it, and things like that. So this is just an overall view of this fluid friction apparatus. Just wanted to give a little bit more information. There are a lot of things you can test with this equipment. For example, if you want to do the sudden expansion and contraction, we'll talk about it in a minute, or if you want to see in a strainer how much restriction is taking place, and if you wanted to see a venturimeter, how one venturimeter behaves, and also how this expansion takes place, and or if you're going through an orifice, how what the pressure head differential would be. So like I said, it has multiple things you can check on, and it's a very universal machine apparatus, and a lot of things you could do it And for this video, I'm just going to focus on pressure, smooth pipe and rough pipe. And one more thing I want to add, since we're doing a part of the smooth pipe, is sudden expansion and contraction. So these two regions are sudden expansion. So you can do the same thing, pressure head loss in this expansion, and here is a sudden contraction. As you can see, the bigger diameter drops down to smaller diameter, and we're using 11 and 12 tap, and using again these taps to measure the pressure head. So in one experiment, we're covering two things. One is friction loss in a smooth pipe and also the rough pipe, and also we're also measuring losses in sudden expansion, losses in sudden contraction. So I thought of just introducing this equipment because we'll be using for the future experiments also, and it gives a kind of a lead into the experiment. Okay, thanks.